On this first page, we are going to be doing the Bohr diagrams. Remember, the Bohr diagrams are the ones where we actually talk about the orbitals, okay? So the first thing that I would recommend doing when you get a request to have a Bohr diagram is going ahead and writing down what is the mass, what is the number of protons, what is the number of neutrons, and what is the number of electrons. That's the first thing I would write down. And when you look for beryllium on your periodic table, which is right here, it might take you a little bit, you will see that the mass is 9.012. We're going to round that down to 9. What is the number of protons we have? 4. We know that because of the atomic number. That's all we needed from the periodic table for this problem. Okay? How many electrons do I have? 4. In order to get neutrons, what do I have to do? 9, which is the mass, minus the number of protons, and we get 5 neutrons. Are you with me so far? Okay, the first thing we have to do is we have to draw the nucleus. And inside the nucleus, we go ahead and we record how many protons and how many neutrons there are. So you would write down 4p and 5n. In each of the orbitals, remember, in the first orbital we can hold 2 electrons. In the second orbital we can hold 8 electrons. In the third orbital we can hold 8 electrons. And in the fourth orbital we can hold 2. Remember, 2882, you just ate a kangaroo. Or just remember the numbers. Whatever floats your boat. So, we are done with protons and neutrons at this point. The whole purpose of the Bohr diagrams is for us to figure out where the electrons are and the number of valence electrons at the end point. So first we're going to do our first orbital. How many electrons did I say could be held there? 2. How many electrons do we have? 4. So we write 1, 2. That orbital is now full. So we have to draw a second orbital, or an energy level. How many can be held in that second energy level? 8. How many electrons do we have left? 2. So you'll draw 1, 2. That one's done. Okay? Let's move on to sodium. First thing that we should do is go ahead and write mass, protons, neutrons, and electrons. When you guys look at the periodic table of elements, what is the mass of sodium, or Na? Yes, it's 22.99, so we're going to round that to 23. What is the number of protons, or the atomic number? 11. What is the number of electrons then? 11, because we're assuming all atoms are neutral. How many neutrons do we have then? 12. We get that because we take with the atomic mass 23 minus 11, and we get 12. First thing that we're going to do is we're going to draw the nucleus. We're going to write how many protons and how many neutrons we have in there. So we have 11p and 12n. How many electrons do we have again? 11. So in the first orbital, how many of those 11 are we going to put in there? 2. 1, 2. How many do we still have left? That's right, everyone. 9. Okay. Second orbital, how many can we fit? 8. 1, 2, 3, 4, 5, 6, 7, 8. So how many electrons have we actually used so far? 10. How many do we have left over? 1 more. So we have to draw 1 more orbital. And you're just going to draw 1 electron. Is this making more sense? Okay. I do not care if they are in pairs throughout, as long as you make sure you spread it out somehow. Don't write like just 8 next to each other. So either pair them up or spread them out around the orbital. Okay? Good question. So let's do sulfur. Rule of thumb, we're going to write down first mass, protons, neutrons, and electrons. Okay, we go to sulfur, we find it on the periodic table. The mass is 32. The atomic number is 16. So the mass is 32. The atomic number is telling me what? The number of what? Protons, but also what else? Electrons. So 16 and 16. 32 minus 16 gives us 16 again. So the first thing we're going to do, draw the nucleus. Draw 16p, 16n. But now we got to take care of all these electrons, and we've got a lot of them. So on that first orbital or energy level, how many can we hold? 2. So let's write down 2. We still have 14 left. On the second orbital, how many can I hold? 8. 1, 2, 3, 4, 5, 6, 7, 8. How many does that add up to so far? 10. So we still have 6 left over. On that third orbital, how many can we hold? We can hold 8, but how many do we have to put in there? 6. So let's go 1, 2, 3, 4, 5, 6. There's our drawing. Okay, let's do fluorine. Yes.
I put them all in here, so
That's fine. That's fine. That's fine. Yep, that's fine. You can do that. I don't care as long as they're just that. If you have the correct number of electrons on each orbital, that's my priority. Okay? Next one, fluorine. First, we're going to write down mass, protons, neutrons, electrons. Let's find fluorine on here, right here. The mass is 18.998, so we're going to round that to 19. What's the number of protons? 9. So that also tells us the number of electrons. The mass minus the number of protons gives us the neutrons. So 19 minus 9, that gives us 10 neutrons. So what are we going to put in the center of the nucleus? 9p, 9e. Yep. N, 10, N, my bad. Good call out, because electrons are not in the nucleus. 9 protons, 10 neutrons, but we do have 9 electrons, right? So that's what we're going to be drawing in these orbitals. So in the first orbital, how many are you going to draw? 2. In the second orbital, how many am I going to draw? How many am I going to draw, though? 7, because 7 plus 2 equals 9. So 1, 2, 3, 4, 5, 6, 7. Go ahead and get that down. Remember, you can get ahead if you feel confident on these, okay? Okay, let's go ahead and flip it to the back. All right. Remember, I messed up right here, so skip beryllium again. Let's do calcium. First thing we're going to do is write down the mass, the number of protons, neutrons, and electrons. What is the mass of calcium? Ca. 40. What is the atomic number or the number of protons in calcium? 20. That also tells us that we have 20 electrons. How many neutrons do we have then? How many? 20 again, because we take the atomic mass, so 40 minus 20, and that gives us 20. So what we're going to write down is the number of neutrons and protons in the nucleus. 20p, 20n. We have a lot of electrons to take care of. So in the first orbital, how many am I going to draw? 2. That still leaves us with 18 electrons. in the second orbital can hold 8. How many do we need to put? 8. So 1, 2, 3, 4, 5, 6, 7, 8. That gave us a total of 10. In the third orbital, how many can it hold? 8 again. Are we going to put all 8? Yup. 1, 2, 3, 4, 5, 6, 7, 8. Are we done? No. How many more electrons do we have left? 2. On that final orbital, how many can it hold? 2. Are we going to put both those in there? Yes, because that adds up to 20. Okay? That's as complicated as it's going to get for you. Okay? I will never give you more than 20 electrons. You will learn about that in chemistry. Okay, let's do argon. Mass, proton, neutrons, and electrons. What is the atomic mass of argon? 40. Yeah, it's 39.948. So we're going to round that to 40. What is the atomic number? 18. So that indicates 18 protons. That also tells us that we have 18 electrons. How many neutrons do we have? 22 is correct. 40 minus 18 gives us 22 neutrons. Okay? So the first thing we're going to draw, nucleus with the protons and neutrons. So 18p, 22n. We've got 18 electrons, so pretty close to the last one. In the first orbital, how many are we going to draw? 2. So we still have 16 electrons that we have to account for. On the second orbital, how many am I going to draw? 8 again. Okay. Now what's our total electron? 10. On the third orbital, I can draw up to 8. How many do I need to do? 8, exactly. So 1, 2, 3, 4, 5, 6, 7, 8. All right, I have a question for you guys. How many valence electrons does argon have from this picture? 8. How many valence electrons does argon have on your periodic table? 8, because it's in that column. Okay, that's how we learned this. Okay, let's do 2 more of these, and then I'm going to have you guys do hydrogen on your own. For nitrogen, let's write down mass, number of protons, neutrons, and electrons. For nitrogen, what is the atomic mass? 14. What is the atomic number? Don't everyone speak at once. What's the atomic number? 7. So that gives us the same number of electrons. What's the number of neutrons? 7 again, because 14 minus 7 is 7. So we're going to draw this. Draw a nucleus. 7p, 7n. How many will I put on my first orbital? 2. How many do we still have left to account for? 5. How many should I put on my second orbital? 5. Yeah. 1, 2, 3, 4, 5. And you could have drawn that outer orbital a lot of different ways. As long as there are 5 electrons, I'm happy. Okay? Okay, I'm going to do 10. You can do aluminum because 10 is easy compared to what we've been doing. All right? So, for hydrogen, what is the mass of hydrogen? It's 1. What is the atomic number? 1. Neutrons? 0, because 1 minus 1 equals 0. Electrons? 1. So we're going to draw a nucleus. We're going to put 1p and 0n. Yes, you have to say 0n. Yes, you have to put 0n. So, you're going to draw one orbital. How many am I going to put in that orbital? 1. Bingo. Feel good about this? Okay. I'm going to have you guys do aluminum on your own. I'm going to move on to the Lewis dot structures. Okay? Here are your Lewis dot structures. Before we get into this, I want to remind you of this. Lewis dot structures are talking about the number of valence electrons, or the outside orbital electrons that are on that atom. Remember that this column has 1, 2, we skip all these, 3, 4, 5, 6, 7. What is unique about this column? Everything is 8 except for helium. There's a blank space here. I want you to imagine taking helium and moving it over there. Okay? So, first and foremost, let's find neon. Neon's right here. How many valence electrons does neon have? 8. Remember that each side has 2 spots, so we're going to draw 1, 2, 3, 4, 5, 6, 7, 8. Great. Okay. What about argon? 8 again. 1, 2, 3, 4, 5, 6, 7, 8. What about beryllium? It's right here. 2. You can draw these various ways, but no, they cannot be paired up. I like to go 1, 2. What about chlorine? Chlorine is right here. 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. All right. What about krypton? 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to let you do xenon on your own. I'm going to let you do fluorine on your own. What about sulfur? Sulfur's right here. 6. So 1, 2, 3, 4, 5, 6. I'll let you do iodine on your own. And oxygen. What about this one? It is 3, so let's look right here. Remember, we skipped this whole section. So what I would do is 1, 2, 3. What about for this one? 5. Well, yes, 5, right here. Okay, so 5th column. 1, 2, 3, 4, 5. So one side has a pair. Everything else is spread out.